Well, it's not Thursday, but it is Friday, because that's the way things work sometimes. And hi, good evening, good morning, good afternoon, wherever you are in the world, and welcome to ADRAMADA, another day of Resh Ask Me Anything Digital Alchemy. Come for the shirt, stay for the news and the project. I am your host, the aforementioned Dave Rush, and you are the Andromeda Armada. We usually get together on Thursday nights at 7 o'clock p.m. Central Time, but my world changed a lot since early January and maybe even a little further back than that. And so I've had to do some flexing and sometimes push a Thursday show to a Friday show, which is what's happening today. Sometimes I mix a powder in here, a powdered drink sometime during the day, and drink it all up, but the ice in there absorbs it. And so when I top it off with water, there's like a hint of flavor. You know, that little hinty stuff that you flavor water with? That's what it's like. Hey, come for the shirt. Ever since I got him, and maybe before that, I mean, I have always been a Godzilla fan, but I have never had a Godzilla shirt. And at least 6 months ago, maybe a little farther back, I started the hunt for a good Godzilla shirt. And you can find them. But it's just not worth paying to me for $45 for a Gojira shirt. And if you look up Gojira shirts, you find the band Gojira and not Gojira. So we were flea marketing this weekend, and look, a Gojira shirt. And we asked the person running the booth how much, and he said $1. So I gave him 100. Oh my goodness. Well, let's see what's going on with you. It'll be a light day, not surprisingly. Concurrent viewers, 0. Telewood gets in the very second. There we go, 4. The very second I put the announcement up for the show. Thank you. What was that? About 5 hours before showtime. And then again, a half an hour before showtime. Shia, so great to see you. Just before we came on the air, 10 seconds before I came on the air, I did a quick glance at my ex and saw that you had reacted to something I posted. I don't know which one. I would never call myself profligate on X. I do a post every few days, every week sometimes, but I had a little bit more to say, mostly communicating with other people this week. And something I said somewhere got me a whole bunch of, relatively speaking, followers, which never happens. Patricia, always nice to see you. So we are in the beginning stages of the next round of, what do we call this? Showtime. Showtime on Discord. It's a movie watch party. And so we haven't picked a title. I threw out Alien and Aliens the other day. I'm still always have as a vote Galaxy Quest, because for me, just can't get enough of that. But I understand that's not everybody's cup of mud. Hey, by the way, Pluto tonight just fired up a new run on the Britcom channel. They just started running, I presume, all of them, all the Monty Python episodes. The funniest quote I ever heard about the Monty Python series was on The Simpsons. Meg says, "I'm a girl. I don't like Monty Pythons, not even the good ones." All right, that's fair. Let's see. Yeah, Friday Pie Day memories. Here we come back. I do miss that. Hackers, classic hackers. I've always been reticent, and I got to face my fear here. There are 10 movies or so that everybody in the world has ever seen. Guess which one is included in that list? That's how it goes. So, yeah, I would be open to that. Everybody loves it. I haven't seen it. I'll probably love it, too. All right, what have I got in notes here? Yeah, we do that. We do this. It's Friday, February 7th, which makes this the same week that we started ADRAMADA 2 years ago this week. So I haven't run 3 years of I'm sorry, this is the beginning of our third year. Beginning of our fourth. Did the shindig last year. Moving to the first anniversary. I'm trying to decide if we did stuff on the second anniversary. This is the third. This is, I don't know. Anyway, it's been a couple of years. We have been cranking along, and while they haven't all been continuous because of the little sabbatical I had to take at the end of 24, we are rolling. And, you know, radio hosts take all of December off and the first third of January. It's not much different than what I've done here. Hey, if you follow it, it's a big weekend for football as the Kansas City Chiefs take on the Philadelphia Eagles. Yeah, that's me. Okay, it's a good movie. I won't watch it until we decide if we're going to or not. But if I don't, I do run across it every now and again on Pluto and would be willing to get through it if we don't do this. Today being the February 7th, what happened today in history? There wasn't much. I think I only picked 3 items or so, and you know, Bocephus is gone, is a fact. And it's esoteric, as you would expect from me. On this date, 1857, French writer Gustave Flaubert was acquitted on a charge of obscenity for his work Madame Bovary. I had to write a report on Madame Bovary. I don't remember if it was in high school or college now, but so it sticks in my head. I did not know that he was charged for obscenity. And I didn't bother to look it up. Some years later, 43 and 14 years later, Charlie Chaplin introduces a new character in a film called Kid Auto Races at Venice. And the name of the character, it's a silent film, so the only reason we know the name is because somebody typed it in on a card. The Tramp, right? That's the character for which he became famous. And the little bowler hat and the little short mustache. Kind of walks like a penguin. And then the last one, in keeping with showbiz, 1974. You're going to know this part. Mel Brooks released his Western spoof film, Blazing Saddles, starring Cleavon Little and Gene Wilder. It premiered at the Pickwick Drive-In in Burbank, California. That means nothing to me, and so unless you're a Burbankian, it probably means nothing to you too. But here's something I didn't know. All the interviews that I've seen with him, everything I've read about him, patrons watched the movie from horseback rather than in cars. So it was a drive-in, and isn't that fascinating? I love that idea. Streaming on Tubi, okay. Yeah, the Super Bowl. I think Hackers gave Angelina Jolie her star. I think you're probably right. And there was a couple other Brat Packers in there, if I understand right. All right, we have social platforms, and I have posted them all right at the beginning of the show, a couple seconds before the show. So if you want to find ways to reach out to us or join us, become one of the few, the proud, the true ADRAMADA Armada, do it. We have a Discord server. I spend a tremendous amount of time online there. I don't spend a tremendous amount of time there typing and reading and everything, but every time something comes up, my computer wonks, and I'll be looking at it in the next minute or so. So it's the ADRAMADA Discord. There's an invite right before the show started in the chat. And my contact information is there. If for some odd reason you would like to contact me directly via email, there's 2 email addresses there. You can catch me on X, formerly the T thing, on at DRushTX, Dave Rush, Texas. And my Mastodon account is pretty much the same, at DRushTX at mastodon.social. No, I don't do that. So, where have we been? Where are we going? Last week, we did a Linux project. And it was a combined pair of projects. One was to use a package manager that heretofore I had never used, Flatpak, to install a package called Resources. Resources is a Linux systems monitoring tool, CPU, RAM, temperature, kind of, sort of, sometimes, maybe, network activity, stuff like that. And it looks and acts very similar to task manager. You can start programs, you can stop programs, you can interrupt services and processes and things like that. So it's interesting. It's nice for people who are working on the big step, making the transition from Windows to Linux. When they see familiar things, that helps make that move. And we learned a little bit about Flatpak. You didn't get to see all the troubles I went through. I like Flatpak once it's working. To get it to work threw me for a loop, and I wound up spending about an hour on something that I believe probably should have taken about 40 seconds. But that's the way that goes, right? All right, this week, show topic image. I don't have a slide for this week's topic image yet. I thought about this all week. For years, literally years, people have asked me in my former capacity to do a course on subnetting. And I'm in the middle of teaching another pair of Network Plus classes, and the material there I find wanting. And so I thought, well, I'll tell you what, I'm going to take a stab at this. I'm going to do it two ways. Tonight is the beginning of a multi-part series. It may take 4 parts, depending on how part 3 goes, if we need more practice or if we need more clarity or more something. So if you're following this, we start projects usually at the half-hour point through the show. And why is Dave going to do this? Not just because people ask him. That would be way too much feeding my ego. Oh, which is enormous. But I learned subnetting a long, long time ago, 30 years ago. And while subnetting has not changed, the vocabulary has changed in a way that I find very bad. It's confusing, and it's not used consistently. Some people do it this way, some people do it that way. And so, I'm going to show my gray beard here, and I'm going to go back to the old nomenclature, and then I'll translate it into the new. But what I bring to the table is 2 things. One, clarity that I don't believe exists in today's zillions of tutorials. And B, the way I learned subnetting was in a crisis. I was on the road teaching a Novell class, and in a facility next to mine, an instructor called in and they said, "Hey, can you cover this class tonight?" "Yeah, sure. What's the class?" "It was some networking class, and they're going to do subnetting." And I, like everybody else on the planet today, went into a hyperplastic panic because I didn't know subnetting. And everything that I knew about subnetting brought fear to my heart. I knew nothing. So I heard how hard it is and how. So I sat down that afternoon, with a book that I was going to teach out of, and I figured it out. Took me a few hours to figure it out, and at the end, it was a head slap moment. Oh man, there's nothing hard about this. And the way I learned it, the way I figured it out, I said, I don't understand this. I really didn't understand it when I got done. But I could teach it, because I can teach the process in such a way that even if you don't understand it, you can do it right very quickly. And then over time, as I began to actually use it in the real world, I started to understand it, and I incorporated that into my classes. So that's what I'm going to bring to the table. I'm going to bring to the table both things. I'm going to bring forth some understanding and some practicality, but I'm going to bring forth what I have been doing for 30 plus years, and that is, you don't have to know what I'm about to teach you, but you got to know how to copy what I'm about to teach you, and you will be able to do this. We're going to start also by laying down the most fundamental foundations. Today is so easy. We're going to do backward and forward, binary to decimal, and decimal to binary conversion. So that's all today's project is. It's very frighteningly easy. If we had time, I'd do 2 examples or 2 practice examples of each, but I'll hand that off to you, and it's so easy you'll be able to figure this out. So this is going to be part 1 of either a 3-part a 3-part or a 4-part series. Next Thursday so far is clear of evening engagements. So right now we're slated to do part 2 next week, which is going to be classful IP addressing. The following week, that Thursday is already booked. So the following week is the week of February 20th. And we're going to do a Friday show like this one, February 21st, which is when we actually do subnetting, which we call CIDR or classless networking. And then depending on how far I get, I may extend that into part 4 on the last day of February, the 27th, Thursday, or the 28th. 1 week later, we've got this booking down. There is a lady that I follow in a couple of arenas. Her name is Maxine Hayes. And we've communicated. We have yet to run into each other in person. I kind of expected at one of the convos I was at last year to do so, but she didn't make that one. But sooner or later. But she posted an article a few months back about a project called Plan 9. And it's kind of a Linux port from the original Unix from Bell Labs. And she has some interesting perspectives on it and how it fits into an educational environment. She's also a Rocky fanatic, as you know I am. So she's coming in as our special guest on March 6th. Maxine Hayes. And we were in touch yesterday and starting to put the details together. So it's a cool, cool thing. Okay, let us slideshow. So we've got a sponsor. ADRAMADA has a sponsor. And it's kind of a trade of services. You know, I'm not making any money off of this. YouTubers, if you're watching this, YouTube management, no money. They're just doing me a favor, and I'm doing them a favor. It is Dartnode, DARTNODE. They are a NOC/hosting organization. You can find them at dartnode.com. One word, no spaces. And they will provide and host your public server. Let me get that up here again. Sorry. Mechanics. I need a director or a producer. And we can't do it remotely, or I'd pick one of you guys really easy. Anyway, they've got virtual private servers. They have virtual dedicated servers. They've got both Ryzen and Intel virtual private server hosting. They have dedicated servers. You call them up and you say, I want my own server. I don't want to share it with anybody. I don't want it on a virtual machine. And they'll say, great. And you spec it out with them. How many processors, how many cores in each processor, how much memory, how much storage, what operating system do you want on it? You can always change that. And they build it for you, custom build it. And then they take it and add it to the rack in the server room. And they don't touch it again unless you ask them to, or unless there's some kind of mechanical problem, or you futz it up and you can't get to the OS anymore to reset it or whatever. They'll do that. VPS, virtual private servers, rentals start at $2 a month. Ryzen 9 VPSs with DDR5 starts at $3 a month. And Intel E5 Xeon started $4 a month for VDS, virtual dedicated servers. You get much less sharing of resources on a VDS than you get on a VPS. Go whole hog, get your own dedicated server. All servers come with your very own public IP address, and you can get more if one's not enough. There's a Valentine's, and you can colo. You own a server. You can buy it from them over time, flat rate, or buy your own and build it and send it to them. And they will install it, and there you go. Get your own addresses, and you got your own specialized super machine. It's awesome. So there's Valentine's sale going on right now, 20% off the first month. Discount code is on the landing page at dartnode.com. It happens to be 2025-love. And love is in all lowercase on their landing page. There's details and restrictions on their homepage. This sale ends February 28th of 2025 at 6 p.m. Central Time. And that's that. Let's go see. Oh, what did you just do? Hey, I got a word. what you guys are talking about. I live for drama. Say what? Friday, you betcha, yeah, sure, yeah. Whoa, super scroll. That hasn't happened in a while. Because we have more people than usual. Though not by many. Reading. Okay, I think hackers gave Angela a start. Tulwood agrees. There was an old admiral who was renowned for his prowess in battle. No matter the fight, he was the man to win. And when things seemed impossible, he would reach in his pocket and remove a paper and look at it, and instantly his countenance would change. His confidence would shine for all to see. Battle after battle, when all seemed impossible, out would come the paper, and he would look. There. An interrupted conversation. I'll come back to Jason's thought here. And he would look like a god amongst men, and the battle would be won. One day the old admiral died. Curious of his secret, one of his assistants removed the paper from his jacket pocket. What was the secret the admiral held? Reading aloud, for all to see, the admiral's secret was revealed. On the paper were written the words, starboard was right, port equals left. I don't know what to do with that. Random question from Jason. Let's talk putty. What can you do besides ping an IP address? Well, I never heard of pinging an IP address with putty. So the job of putty in its first 4 simplest iterations is to establish a terminal connection with a device that can run either Telnet, SSH, modified standard ports, a serial port, and I think there's a 4th one on there. It's a terminal emulation tool. Simple, straightforward. So yeah, if you use it and try to contact some server and you get any kind of response, including your response was rejected, I know that server is up and running and knows what to do if it gets a port 22 call or a port 23 call or a bitbang call to the serial port. But we can talk more. I don't think I have a good understanding of what putty can and can't do. Oh man, there's so much that it can do customized. We can incorporate certificates into it and other preset security features. And okay, you got me convinced. Notepad, bottom, do an all-out putty show. Save. Okay, we'll be doing putty. Did that. Okay, next is going to be news. Moving on here, Patricia. But is it your right or facing the ship? Your right or facing the ship? Right, sweet. I remember when they came on the show. I need to get them back. I can generally talk about the knock operations now, and there's always more subtleties to it, but and more real deep techo stuff. Because there was so much that I had to learn from him yet about a lot of the internal routing and things like that's going on. And love to get him in here to talk about BGP when we do that, BGP peering. But what I really want to get them to talk about right now is their current involvement with the next trip to the moon, the Firefly, Blue Fly, whatever it is, the something fly. They're doing software for that mission. No, nothing. Sorry, but it was a good story, and it gave me a chance to read extemporaneously with dramatic flair. Man, I gotta add words to my spell checker. It can't spell. It thinks I misspell really obvious, easy things like impactful. It thinks that's not a word. All right, well, let's take a look at the news and see what's happening. Where are we at time-wise? 6 minutes. That's perfect. There wasn't a ton of great news this week that I felt really required sharing. Slide next. Okay. Need to rearrange my screen so I can see what's going up on screen and see my notes. So there is a new approval for treating Parkinson's by the FDA just this week. They approved sale of this treatment. What was so awesome about it? Oh, it's an infusion, and that means long, slow provisioning. There's a lot of ways to do infusions, and I am not much of a medical background. I was an EMT a couple thousand years ago for not very long. I'll tell you that story someday over a beer. But usually an infusion goes into some is an injection into a bunch of muscle where it will slowly release, or the more common way is into a fatty part of your body, under the chin, belly fat, and they can do infusions that will release for 2 weeks to a month on that. Well, this particular infusion is a subcutaneous device under the skin, and it slow releases into intramuscular, intrafat, whatever it may be. Dump it off a couple of drugs, and it's designed to work between the normal meds that Parkinson's sufferers experience. So when this med is fading in effectiveness, but you got to wait before you take your next treatment, hours, whatever it is, then this thing turns on, or maybe it's already on and just provides a little smooth out and avoids tremors and things like that while you're waiting for your normal next dose. So I find that interesting. Parkinson's and dementia, that's a couple. I know people who are impacted by both, and so I feel a little bit closer to it. And I'm planning on getting them both myself over turn. I was kind of excited about this next article, and then as I was going through all my normal tech sources, I ran into a second article that made me say, oh man, that first one was just clickbait. But the article, self-healing asphalt. Did they specify the university they came up with? Yeah, but I didn't write it down. Anyways, self-healing asphalt was... The idea for it has been credited to some AI monster. Not exclusively, obviously, but it got a lot of credit. And the general idea is tiny plant spores filled with recycled oils are placed into potholes, and they effectively grow these oils into asphalt and make a material that can mend its own cracks. Okay. I accept. That was the article that I read. And then I found the other article. This is in the very earliest stages of research, the only lab experiments that they've done, and they have done lab experiments. This advanced asphalt material was shown to completely heal a micro crack on the surface in less than an hour. So, I don't know, does that bode well? Does it seem like something we're going to be able to take something like in the image here and in an overnight or in a day take care of it? I don't know. So, turned out to be not as interesting, but I needed 7 items, so I'm leaving it in. Another early developmental. They are doing all kinds of things with fabrics. Various kinds of smart fabrics. They grow, they shrink, they do all kinds of things. This one, sunlit fabric heats up in sunlight. That seems like, why would I want that? But there are plenty of sunny days, really, really bright sunny days, when it's wicked cold. Right? So it's cold out, it's daytime, you're warmly dressed, but you're still cold. Or maybe you're not warmly dressed. Maybe you're underdressed but you've got this magic stuff. Fear not, the next generation of warming fabric is here, actually coming. New smart fabric generates heat from sunlight to keep you warm in freezing temperatures. And while it's doing it, the more heat that it generates, it changes color from whatever its default color, kind of a greenish thing from the photos that I saw, to yellow to red. And how good is it? They've made lab samples that are actual clothing out of it. Scientists at the University of Waterloo, I love the University of Waterloo, they made some of the best programming language versions. Watt 5, Wattcom, Watt Basic. I used Watt Basic for a while. Anyway, they're working on commercializing this smart fabric, makes sunlight into heat, ideal of the material made into clothing in extremely frigid climates. Well, how warm does this stuff get, you gotta wonder? It's a soft fabric, impressive warming capabilities. Material rose from an ambient temperature of 20 degrees C to 53.5 degrees C in 10 minutes when exposed to, they give some tech numbers here, bright sunlight, bright solar radiation. In Fahrenheit, that's a 60-degree Fahrenheit swing. So from 68 degrees to 110 degrees, something like that. Wow. Fabric color shifted from red to white. Other way around. I was backward here. So we can watch it. And once cooled, the fabric returns back to its original color. So that's fascinating. My eyes. Earth is not the only place in the solar system with canyons. We've got a pretty good one here. The Grand Canyon. It's very long. It's somewhat deep, 1,800 meters or so at its deepest. Well, there's plenty of craters on the moon, and they obviously were not formed in the same way that Earth canyons are formed. No moving water up there, no winds or blowing dust or anything like that. So scientists have always speculated it's asteroid hits, it's seismic activity that caused some welling up or things like that. So a couple of scientists or some university said, we're going to take a look here. David Kring of the U.S. Lunar and Planetary Institute wanted to do a close exam of a pair of them. So there's these two canyons on the dark side near the south pole of the moon. And they're pretty big. One of them's 280 kilometers long, 3.5 kilometers deep. And the other one is not so big. What's interesting is when we compare how long it took to make the Grand Canyon, a couple million years, several million years, these two were created. I've got another slide here that gives a little better perspective. It sounds kind of hard. There we go. So you can kind of see there's a crater down here, bottom center, and then up running toward 10 o'clock position, there's this long one. That's the 280 kilometer one. And then straight up to around the 12 o'clock, 12:30 position, there's a smaller, narrow one. This crater is called Schrodinger's crater. One of these canyons is Willis Schrodinger, Willis Canyon, and the other is Willis Planck, like Max Planck. Well, what's cool about this, they figure it was the asteroid that struck and created this crater, blew out ejecta all over the place, and created those two canyons, in about 10 minutes. Now, do we care about that? Yes. Because we now have, as of this week, a new analysis of an asteroid that has the size and the odds of an Earth strike that are something to truly pay attention to. This asteroid was found a year ago, and it wasn't spotted a year ago. It was spotted by some scholar going back through years and years of photos and images, and hey, I found something moving here, and he found that last year in the photos. So they made some initial estimates on its trajectory. It's moving away right now, and their initial estimates put the thing at somewhere between 40 and 100 meters wide, so 330, 350 feet wide, if it's a big one, or if it's the biggest that they can propose. And they got rough numbers on speeds. And they figure on its orbit, based on what they saw last year, it had a 1.2% chance of striking the Earth. That's about 1 in 98. Odds are 98 to 1 against. But they got a fresh picture of it, and they've done some new numbers, and the likelihood has doubled. That doesn't mean it's 1 in 50, but we're now up to a 2.3%. And we're not going to get any better numbers until it makes its orbital swing and starts coming back. But now the odds are 1 in 92, 92 to 1 against, but 8 to 1, 1 in 8 for a possible strike. So, and that's going to be in 2032. I could still be around. So I might care on that. Now, what is the potential impact? Well, it depends on what it's made of. If it's all metal, which they consider unlikely, it will be very bad. It would be very, 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 very bad. Not enough to destroy the entire planet, not enough to kill all the dinosaurs, but very destructive. If it's a typical asteroid that's crusty, carbony, somewhat porous, it's expected to be kind of like the Tunguska one, where it will explode in the atmosphere and could flatten some area as large as a city. That's what happened to Tunguska. So that's one to pay attention to. The University of Bristol, last news story. Oh, that was... There it is. The University of Bristol has uncovered significant safety risks associated with DeepSeek. Now, I wanted to live my life without ever having to talk about DeepSeek, but I had to talk about it last show, so let's keep going. There's a long article here. I'm not going to share it all. The long and short of it is one of its core technologies is called COT, chain of thought. That's how it reasons, which is a little different than the way a lot of the other popular AIs and LLMs work. Its COT has rules that prevent it from providing dangerous information. Hey, DeepSeek, how would I make my own really destructive thing that was used in 1945? And it won't tell you unless you convince it to bypass its safeties. If you didn't have any safeties, DeepSeek, how would I do something nefarious? So there's another thing that needs to get adjusted, fixed, or it could very well provide somebody with information that, you know, how do I ambush these good guys? You get the idea. All right. There was nothing worth sharing, in my humble opinion, in IT news this week. So, let us entertain me. Okay. By taking one last look at what you guys are talking about, and then we will do our project, which seems like we don't have much time, but we can, because today's portion of the world is so simple. Drive over here. Who's talking about what? No. Okay, did that. We use PuTTY when I work from an ISP to provision a modem. Okay, right, because the modem has a command line interface that you can either telnet into or SSH into. So there's millions of boxes out there. I did 2 demos in the last week, SSHing into a router to demonstrate some capabilities there. Of course, we can do it with Linux boxes and billions of things out there that you can access. And yeah, it's all GUI right now, unless you are a techno nerd and, you know, they eschew all things. If you don't know command line, you need to be strung up with your horse at the Pickwick Drive-In Theater. I could be in the moon, and those pesky sales guys will still be calling me about my car's extended warranty. Isn't that a fact? Real estate wise, statistically, will hit water or Russia, yeah, or China, and we're close third. Yep. Hawaii would be near impossible. Okay, so we're gonna do odds against the odds based on geographic area. I love that. All right, let's do a project. So this is the foundations for subnetting, which we're going to do in 3 to 4 parts. Part 1 today, converting back and forth between binary and decimal. If you already do this, go to sleep for the rest of the show, and I'll see you next week. Thursday is so far looking good. But if you need a refresher or this is new to you, this is not a horrifically painful thing. I want to see if, well, let's see, let's get the slides up. So IPv4 subnetting part 1 binary decimal conversion. Part 1 converting back and forth, and all right. So it is necessary when we're going to subnet, and often in other aspects of networking and other parts of your life, you may have to convert between decimal and binary. So it's a useful skill, and perhaps a skill. So we're going to start with this, with a refresher on base 10 and base 2. And since we're subnetting, we're going to think about binaries in terms of 32-bit numbers, IP addresses. And the spacing didn't work out as well as I'd hoped on that one. But what we've got here is 8 bits separated by a dot from another 8 bits, dot another 8 bits, dot another 8 bits. And down here there's 32 bits. Now I could whip open some calculator and type in those 32 bits and it would give me a very large number. Somewhere I'm looking at that thing around the 2 billion mark. But we cannot think in terms of numbers that large without paper and pencil and computers and calculators. So whenever we're working with binary numbers in the IP address world, we break them up into 8 chunks of 8. And that's why we have these dots here. It humanifies them for us. So I can say, I only want to work with the first 8 bits, which we call an octet, or the second or the third or the fourth. So let's go start this game by doing a refresher in base 10 number systems. This is so ingrained in you that it's pointless, except we're going to use it as foundations to switch back to our binary, which is also a base 2 system. So if I give you this number, 8107, and you know what it means. You know that's 8,107. But if we have to go back to when we learned why that means 8,107, we might remember doing columns. And so, because we're a base 10 system, all base X systems start with a ones column. And then the next column to the left of that is the base multiplier. We're a base 10 systems, so 1 times 10 gives us the tens column to the left. 10 times 10 gives us the 100 columns to the left. 10 times 100 gives us the thousands column. If you were working in a base 8 system, it'd be 1 times 8 gives us an 8s column, times 8 gives us a 64s column, times 8 gives us a 4, you get it. So, okay, if I want to figure out what a number means and it's just 4 digits that somebody's handed me, then what I'll do is I'll put each of those digits under their respective column, and then I will calculate and add. I start with whichever side I want. I'll start with the right side on this one. I'll say 7 is in the ones column. So I'm going to say 7 times 1. Oops, I made an 8 here. Oh, I went left side. Okay, I'm going to start on the left-hand side. So 8 is in the thousands column. So I'm going to write down 8 times the column value. 8 times 1,000 is 8,000. And then I'll go to the next number over. 1 is in the hundreds column. So 1 times 100 1 times 100 equals 100. Working on the right-hand side. 0 in the tens column. 0 times 10, looking at that calculation on the right, is 0. And then in the ones column, I got a 7. 7 times 1 equals 7. And then I'm going to take all those equals that I came up with, the 8,000, the 100, the 0, and the 7. I'm going to add them all up and come up with 8,107. We go back. That's exactly what we said. And again, this is so natural and native to you because you've been doing this since you were 6 or 7 years old. It's not significant. But what we're going to try to do here is use that as a foundation for binary. Before we do that, I want to show you a trick that you already know, but probably never thought about it this way. If you have a set of numbers that are all 9s in a base 10 system, and they're all next to each other, 999, and you increment that by 1, you add 1 to it. Well, because of the fact that we can only number 0 through 9, and then if you get more than that, you have to turn it into a 0 and carry the 1 to the next column, and that's going to happen again, and that's going to happen again. The shortcut way to remember this is if you have 3 9s in a row and you add 1, turn them all into zeros and increment the next column by 1. So if this was 29.99 and I added a 1, all the 9s would turn into zeros, and the 20, the 2 under the thousands column, would increment to a 3. Okay? It's not a big trick, but I'm going to show you how we can make that work in a binary system as well. That's going to get kind of cool. All right. Converting from binary to decimal is the easiest task in the world. I can do this with one slide because we're going to do it exactly the way we did a base 10. The only thing you have to remember, and folks, if you're watching this, because there are some people I recommended to watch tonight's show and the upcoming shows, if you're watching this to prepare for, I don't know, some kind of networking exam, the first thing you do before you take any questions is you take your handy-dandy little whiteboard or electronic whiteboard and you write down 8 numbers, the base 2 numbers. You can do them left to right or right to left, whatever works best for you. Always starts with a ones column, and each column is a 2 multiplier of the preceding column. So we got a ones column. 1 times 2 is the 2's column. 2 times 2 is the 4's column. 4 times 2 is the 8. Times 2, 16, times 2, 32, times 2, 64, times 2, 128. These are the value columns in a binary numbering system, in a base 2 numbering system. In a base 2 system, we've only got 2 numbers to work with, zeros and 1s. So I just picked a couple of random 1s and 0 patterns here and wrote them down in the column, 0, 1, 1, 0, 0, 1, 1, 1. And to calculate this, you do it just like we did the base 10 system. I got a 0 in the 128's column. So over on the right side, 0 times 128 equals 0. I have a 1 in the 64's column. So 1 over on the right, 1 times 64 is 64. Do that for every place. 1 times 32. Oops, I missed one there. I missed a 32. I was whipping these slides out 20 minutes before showtime. So we'll fix that. Let me shortcut. Skip the zeros. 1 times 64 is 64. 1 times 32 is 32. 1 times... The trick here is if you just add up the column values wherever you have a 1, you'll come up with the final value here. So 64 and 32 is 96. Plus 4 is 100, plus 2 is 102, plus 1 is 103. So this is not supposed to be 87. I missed an entry there. It's 103. Sorry, sip of water. All right, I got another trick coming down there. So I think I made another example to try. Yeah, this is the step-by-step. So step by step, if you're going to get a question that you have to answer like this or a real life situation, start by writing down the 8 column values. 128, 64, 32, 16, 8, 4, 2, and 1. Or do it the other side. But always keep the bigger numbers on the left. And then take the binary number that you're supposed to convert. Here's one. 1101, 0110. And again, I'll use the short method here. I don't have to say 0 times 32 is 0 and put that in some add up. All I'm going to do is add up the value of the columns that have ones in it. So here's 128 on top and on the left. There's a 1 under the 64. So the formula on the bottom has a plus 64. The next time we have a 1 is under the 16s column. So plus 16. And then we've got 1s in the 4s and 2s columns. So plus 4 plus 2. Add all those up. 128 plus 64 plus 16 plus 4 plus 2 equals 214. So converting binary to decimal is the easiest thing on the planet if you remember your column values. Now how about doing it in reverse? You get a decimal number and you have to convert it to binary. It's not much harder. It's just a little bit of a different approach. So we start with the number in question, 179 I have on the top of here. And I'm going to write down my 8 columns. And the trick to this one is you put a 1 in the highest column that is equal to or less than your target number. So my first column is 128. That is equal to or less than 179. So I'm going to put a 1 in there. And then I'm going to take my target number, 179, and I'm going to subtract the column value from that. 179 minus 128 is 51. This is the new number that I'm going to work for in binary. So next one is, if I change the top of this one, decimal 51, I think I'll do that. I look at the next number in the column values and I see 64. 64 is not smaller or equal to my target number of 51. So I'm going to put a 0 there. And I look at the next column and it's 32. 32 is equal to or smaller than my target. So I'm going to put a 1 there. And I'm going to subtract 32 from 51. 51 minus 32 equals 19. Sounds good. That's my new target. Now I got to figure out the 1s and 0s necessary to make a 19. Well, 16 is the next column I have to work with, and hey, good news, it is less than or equal to 19, so I'm going to put a 1 there, and then I'm going to subtract 16 from 19. 19 minus 16 is 3. Now at this point, your logical brain could, should, would be able to stop and say, what columns can I put numbers under to come up with 3? And you can do that, but I've got it all step by step marked out, so I'm going to step by step through it. So my next target is 3. I look at the next column. 8 is bigger than 3. Too big for 3, so I'm going to put a 0 under it. How about the 4? That's too big. It's bigger than a 3, so I'll put a 0 under there. Ah, the 2 is less than or equal to 3. So I'll put a 1 in there, and I will subtract 2 from 3. 3 minus 2 equals 1. And that's my final target. Now I got to figure out how to make a decimal 1 into a binary 1. Doesn't seem like a particularly tricky thing to do, does it? Next column is a 1. I put a 1 in the 1s column, subtract the 1s column from my target, I get 0. I have completed the conversion. 1011 0011 is 129 decimal. Cool. All right, there's only 2 things left, and here endeth the lesson. thing number one. There is no, you can express 255 possible values with 8 bits. All zeros is 0, and all ones is 255. 0 through 255 is 256. Okay. There is only one way, one pattern of ones and zeros that will make 179. It's exactly this one, 10110011. And the same is true for any other number between 0 and 255. So there's no way to scramble them up and say, well, I'm going to make 179 this way. It's kind of like you guitar players or you other instrument players. If I'm going to do an A, I'm going to do it top fret, 4th string, or I'm going to do it 5th fret, 3rd string. And they're going to sound almost exactly the same. Well, they're going to be an octave off, but there are multiple ways to make A's on a musical instrument. There are not multiple ways to make a given number in a binary octet. And the last thing, I love this thing, because now I'm going to take us back to that trick that we used with base 10. Remember we said base 10, if you had a string of 9s and you added 1 to it, all the 9s turn into a 0, and the next column over increments by 1. Well, exactly the same thing happens in binary. So let me give you kind of a magic hint. This is really cool, and I'm going to give you 2 perspectives to look at it. On my top line in the graphic here, I've got 5 1s and 3 zeros, leading zeros. If I increment that by 1, all of the existing ones will turn into zeros, and the one in the column next to it, to the left, will get incremented by 1. So A, that's a trick. That's a useful, stunning trick. Let me give you a sentence why, or 2. Because when you have a string of 1s, they all add up to 1 less than the next column to the left. So I don't have to figure out that 16 plus 8 plus 4 plus 2 plus 1 is 31. I know that if the 16, 8, 4, 2, and 1 columns all have 1s, that's 1 less than the 32's column, so that's 31. So if I said to you, what is... Yeah, that's too weak. Okay, let's do it this way. How about I have a single leading 0 and 1s from the 64 column to the 62, or to the 32, to the 16, 8, 4, 2, and 1. 1 0 and 7 1s. That's 1 less than the leftmost column. So I don't have to add 64, 32, 16, 8, 4, 2, 1 to come up with 127. I know visually that's 127. So let's apply that here. Let's try to figure out a decimal conversion to binary, and the decimal number is going to be 39. We'll start the usual way. The 128's column is too big. I'll put a 0 in there. The 64's column is too big. I'll put a 0 there. The 32's column, hey, that's equal to or under 39, so I'm going to put in a 1 in there, and I'm going to find out the difference. 39 minus 32 is 7. Hey, look at that. Now, 7. Cool. Looking up on top of the columns, 7 is 1 less than 8. And that means if I put a string of 1s to the right of 8, 1, 1, 1, that makes 7. So it's really easy to make a 39. It's 32 and 7. Is that a cool trick or what? Because I think it's just the coolest thing in the world. All right. Make up your own numbers. Make some examples. Watch this again. It's only a half-an-hour presentation. We finished right about on time. And so, check the final comments and get you ready to wind up. We've got a minute to go. That's just about right. I love some of the things you guys say. I'm watching CS50 class from Harvard Online. They taught binary via rows of light bulb. You can do that. Dave is better. Oh. Said no one ever. Nerd. And it's good. I'll be grading on a scale. All good. Thank you. Is the opposite of increment? Oh, God. See, I managed not to read that all aloud. All right. Well, guys, has been fun as ever and always. Reminder from our sponsor, Dartnode. They rent and sell and host all kinds of servers, virtual private servers, virtual dedicated servers, Ryzen and Intel virtual private servers, dedicated servers, co-located services, starting at $2 a month and going north. But all these VPSs and even VDSs you can pull off for under $4 a month. And there's a Valentine's Day sale going on right now. 20% off the first month through the end of this month, 6 p.m. Central Time. Get the code 2025-LOVE off of their homepage at dartnode.com. Talk about the upcoming schedule. So let us entertain you as we get ready to wind up. Oh, you know what? I'm going to do it that way here. I'm going to do this. I'm going to go over 20 seconds. You know who we were missing today? Joey Quetzal. He's usually available on Fridays. No, we did get a few people, though. All right, now we are ready to do the final wind-up and the big wave off. As ever and always, I wish you a great rest of the week. Not much less of it, so great weekend and football if you're into that. We'll see each other another time. Take care of each other. Take serious steps to stay healthy and if at all possible, call or visit your parents. Never forget, technology is great. You are the greatest resource that we have. And until the next time we meet, I bid you good night. I'll see you on ADRAMADA next Thursday for part 2 of subnetting, classful addressing, and on the other platforms that I'm on. Until then, remember, how you do anything is how you do everything. Eat up or ah.